everyone, and thank you for attending our virtual meetup hosted by Coveros and Inflectra. I'm Kim Trott in Business Development and Partnerships here at Coveros. I wanted to just give you a quick rundown of today's agenda. Our three presenters will be discussing spiraling into quality pipelines. I love that we call it spiraling. Adam Sandman, director at Inflectra, will discuss quality through end-to-end traceability, how spiroplan enables progress tracking and visualization through dashboards. Jeff Payne, our CEO here at Coveros, will talk about quality gates, forcing functions to bake quality in. Then Hugo Sanchez, managing consultant at Coveros, will go over delivering quality through your DevSecops pipeline using spiroplan. Jeff will jump back in and review lessons learned from years of building quality through pipelines at Coveros. We'll do some Q&A followed by meet and greet in creative spaces where you came in. Take it away, Adam.
Okay, thanks, Kim. So if we go to the next slide. And the next slide after that. Okay, just to say hello, my name is Adam Sandman. Oh, you can go back. And I've been involved in technology for about 20 years. Originally was a programmer, started on the 8-bit systems back in the day, grew up in Great Britain, moved to America, love technology. Technology is my passion. So, I mean, it's great to be able to talk to you today about technology and quality, but really technology is in my blood. So my role at Inflectra is a director here of technology, helping to do thought leadership and outreach. So this event is great. It's a chance to talk to you and learn about some of your problems and how our technologies can help. At Inflectra, our goal is to bring harmony to your life cycle. That's our goal, and that's done in many ways around testing and quality and risk management and DevOps. We'll talk about some of those specific ways, but our overarching mission is to improve the harmony and quality of the way we deliver software. Despite all the tools and all the methodologies and all the advances, and since Agile, I think there's still a lot of failure, a lot of problems in systems being released, and so our goal is to make that better. Next slide. In this talk, in my part of the talk, I'm going to be talking about how you can improve your quality by understanding what is quality, what is traceability, and why is that important? And then also a little bit about how our tool spiroplan, that we'll be seeing more of later, it can be used to really help that process. So if we go into the next slide. The first thing, and this is often misunderstood, I think, by a lot of people, is what is quality? And if you come from an engineering background, like real mechanical engineering, I think you have a different view than if you come from, say, a software engineering world. A lot of times in software, we have this feeling of perfection. That means it must be 0 bugs. 0 bugs must go out, and that's perfect quality. And quality actually, in an engineering sense, is really just one thing: fitness for purpose. But what that purpose is really varies on your client, on your industry. The fitness for purpose, if you're building an air traffic control system that tracks the movement of planes, and we have clients who do this, that's a very different quality threshold than if you're building an e-commerce system. But that has credit card numbers in it, which is a different level of quality than if it's a system that just tracks internal information like an intranet. But the quality also factors into the business objectives, because if you release a system that's completely bug-free, it might be 6 months late, and your company's been oversold by another competitor that got to market faster. But that's, for your industry, might be critical. So understanding quality is fitness for your purpose. What are your objectives? What are your business goals? And the quality must be appropriate for that. And if you don't understand your business goals and the drivers of your company and the measures of success, then you've got no way of measuring quality. As I said, it's not an abstract set of data. It's really tied into your business goals. And next question. Next slide. Another factor that comes into quality that I find very interesting is quality control versus quality assurance. Anytime I go to a testing conference, like the Great Star conferences that TechWell puts on, everyone always says, I'm a QA tester, or I'm in QA, I'm in testing. And yet, I used to work in a steelworks. It's one of the things I did for a summer. It was a very interesting experience where you worry about molten metal being dropped on you, and that's quality, safety and quality. But in steel making, there's actually a very big difference between QA and quality control. Quality control is, at the end, you make the big lumps of steel, you measure the steel. Does it work? Is it the right steel? Does it have the right metallurgical properties for whatever it's being used for? And different steel, it has to go in a tin can versus in a car. It's completely different grades of steel. But what they do in a steelworks is they don't wait till the end to test this, because then you just throw the metal out. It's useless. They actually measure the entire process flow from beginning to end, and they measure the chemical composition, the temperature, all these factors at every single stage, from liquid steel to rolled steel. It's amazing, actually. And they measure it so that when they see a deviation in something, when they've got liquid steel, they can actually fix it before it ever gets rolled. So quality assurance, which is this process, is not waiting to the end to test it. It's actually testing the process as you go along, so that by the time you get to the end, when you have this finished product, it's right. Because at the end, in hardware and materials, you can't just go fix it like you can in software. So I think if we apply that lesson back into software development and the idea of shifting left and pipelines, it's exactly the same. It's an analogy, really. If we wait till the software is released to test it and fix it, it's very hard to change. The architecture may be wrong, security, performance, it's all very hard to get right at that point. So we should be testing as we go along in smaller doses. And it's just like being in a steelworks. It's more expensive at the end. So I think if you shift your mindset from a testing quality control method approach to real quality assurance, as a tester and being in the QA discipline, you should be involved right at the beginning. And so that's why I think a lot of times when people say they're QA testers and I'm testing at the end, it drives me nuts, because you're not really QA, you're QC. So that's really important for me. Next slide. Next slide, is it? Okay, thank you. Okay, cool. So that's, in my mind, what quality is, and quality assurance versus quality control testing. So what is traceability? Well, traceability means a lot of things to different people, but it's really being able to follow the flow of information, to find dependencies and find root causes. So there's many kinds of traceability, but it is fundamental. Traceability is linking all the information you have, all the data you have, to make informed decisions. As you know, in this economy, data is becoming much more powerful, and the tools and the methodologies we have give us so much more data. But traceability is the act of putting all that data together to make decisions. Because without that, all we're doing is flying blind. Next slide. So why does it matter, is the question. Well, this is an interesting one, because actually, I remember hearing a story at I think it was one of the Star, I think it was Star Canada. The guy, one of the chief engineers from Boeing, came in to talk about traceability. And when you're in a safety environment, traceability is incredibly important, because you have to be able to prove that you know where something comes from and why something was done. So for example, there's different kinds of traceability, which we'll talk about when we get into some of the latest slides. But traceability, for example, can include things like, I've got all my requirements, I've got all my code. Do I know that all my code has at least one requirement? And you might wonder, well, what does it matter? If the code works, who cares if there's a requirement linked to it? Who cares if I can prove why we made that change? Well, when you're building a piece of software that's going to live for 2 years, that's probably okay. But when you're looking at something like the 737, a platform that's been around since the 60s, it's got more lines of Fortran than any other application I think out there. It's incredible. You're going to be building on top of this year after year after year. And if the foundation is not solid, you can't build on it. So Boeing had a supplier deliver them to an undercarriage with the software component to control the undercarriage, and it worked perfectly, but the manufacturer couldn't verify why all the lines of code had been written in a certain way. There was no traceability, and Boeing threw it out and said, we don't want it. We can't accept this. You've got to start again and do it from scratch. Because even though it's going to cost us twice as much to get it done a second time, 20 years from now, when we try and improve this feature or improve the system, we won't have the confidence of knowing why it works a certain way, and it's too dangerous for us in a safety application. So traceability can literally mean your product gets thrown away. It's that important. Now, for different industries, it is actually even the law. So if you think, well, I don't need traceability, I just want to go write code, run some tests, see what happens. Well, I've got news for you. If you work in any of these industries, aviation, medical, automotive, Not going to happen. You've got to be able to prove to an independent auditor why stuff was done, how it was done, and why decisions were made, and it's got to be proven. And I think with things like GDPR, data privacy, AI, this is only going to become more common. Even in industries that maybe traditionally don't have to deal with this is going to become the norm. You have to be able to understand why something was done, where it ties back to. So traceability is increasingly important, even in an agile world, maybe more so. And I was watching Apollo 13 a few weeks ago before I put the slide together. And one of the things that stood out to me is when the bad thing happened, the explosion, the oxygen tanks were stirred and it blew up. Everyone's screaming and trying to figure out, is it a diagnostic error? Is it the sensors wrong? Is it a real error? Well, the ship's spinning out of control, so it's probably real, it's not diagnostics. And everyone's panicking and trying to figure out, looking at all their sensors. There's like 20 engineers all looking at 20 different screens. And Gene stands up and says, well, let's calm down. Let's work the problem. Let's try to understand the root cause. Let's not make things work by guessing and trying things. And yet when software goes wrong and we have a help desk and tickets come in or people are trying to figure stuff out and they don't know why something broke, there's an immediate tendency to, let's fix all these bugs. There's like 20 bugs. Let's go fix them all. Let's go release code, drop into the pipeline, let's go. And yet at times I think it's really important to take a step back. It takes courage, but step back, find the trace where things are coming from, find the root cause, because otherwise you can make things worse. And also it's hard to diagnose if you're changing everything because you've got no baseline to compare against. So when it comes to quality and traceability, it can help you find the root cause of a problem versus treating the symptoms. Next slide. So that's some of I think the background as to why quality is important and what it means, traceability, what that means and why it's important. And then we're going to be looking a lot at spiroplan, both in this presentation and some of the later ones. Spiroplan is our tool to help you manage quality and traceability. So if you go into the next slide, it gives you visibility throughout your infrastructure and your entire pipeline and your process. So one of the things also when you're looking at spiroplan and you're looking at managing a DevOps pipeline is, what do I measure? And oftentimes people will focus on what we call second order metrics rather than first order metrics. First order or primary metrics are the things that we think are the most important. And it's not tests and test cases and test counts and test activity. Everyone's always thinking about how many tests ran, how many tests passed. That's not a primary metric for us. It should be requirements. There's the features that you have. Features have business priorities. They have criticalities. Your tests should tie back to those. Because if a test fails, how important that test failure is very much dependent on which requirements does it link to, and is that requirement the most important part of the application? Is it a less important part? That does determine it and the criticality. Similarly, people often always forget about risks. We're always fixing bugs and issues. Risks are another very important primary metric. They are the things that you don't know about or the things you do know about, but you don't know if they're going to happen. Tracking risks and being able to plan for them is really important, and being able to test for risks. If you have risks that you've identified, guess what? You can put a test plan in place. You can actually investigate and experiment to try and mitigate and reduce risks before they happen. And then the defects and issues that do occur, that's the other third primary metric. But when you do have defects, it's very important from a traceability standpoint, not just to look at the defects in isolation, look at the commonalities, look at what they connect to. Do all these defects belong to one feature that we released? Okay, maybe we need to take a step back and look at that feature. So requirements, risks, and defects in our mind are the primary metrics, and then the tests and the mitigations and a lot of the code, a lot of the other aspects are the secondary metrics that feed into that. And in spiroplan, those are the three primary artifacts that drive everything else in the system. If you look at spiroplan's dashboards, this is the general dashboard when you first come in. What's right in front of you? On the left, you've got requirements completion. How done am I? Done meaning tested, not just coded. And ideally into the pipeline, integrated all the way through. On the right, you've got risk summary. What are my risks? What's my distribution? Have I got a whole bunch of really likely, really dangerous risks sitting out there? How am I actively mitigating them? And then obviously the schedule and other more traditional project management metrics follow under that. Next slide. And then obviously, when we talk about tests and defects, here's another typical dashboard. Guess what? The top left item is not test cases, it's requirements. Requirements burn down. How are requirements doing? Are we on track? Are we behind? Requirements test coverage. These are some of the metrics that are really important in the system and should be driving your decisions. And similarly, the defect counts. Defects are really important, but tying them back to requirements is really important, finding the commonalities. Next slide. And so when we go beyond the dashboard, another really important part of the system, which we'll be seeing, is test coverage. That is the idea that I have all these requirements and they've got different business priorities, and it's really important that certain ones go live, other ones maybe more ancillary. If there's a problem there, we can work around it. Understanding your test coverage, business priority, system criticality, commonality of those features. Is it a common feature that is required for every part of the system? And then looking at the test coverage that goes with that. Where are my passes? Where are my failures? To understand what is the business impact of a failure? How critical is that? One test case could potentially touch every requirement in the system. If that happens, this entire grid will go red. Whereas if a test case fails and only touches one screen, one line will go red. So it's really important to understand what is the impact of a failure. Next slide. And then traceability to code. I talked about this with the Boeing example. Having tools to help you get traceability to code are really important. But one of the things we've seen is that developers often want to hide this information. They keep it close to them. So the developers are all working Git. They've got tools like Gitkraken, whatever. They can see all the code changes. They can see all the diffs, everything that's going on. The testers, oftentimes who are not involved directly in the code, they'll see a new pipeline job activate, they'll look at the commits. They can't look into this level of detail. And so when someone says we changed one thing, that the risk is only to this one screen, if the testers can look at that and say, actually, you touched these 5 other lines of code, I think these other screens should be retested. A second pair of eyes is really important, and therefore it's really important to have all the team be able to see requirements, test cases, code all together. Don't let just the developers have that view. It needs to be an integrated view for an integrated agile team. Next slide. Okay, so that's a little bit of overview of spiroplan, quality and visibility and dashboards. I want to now introduce our implementation partner, Coveros, and great friends. And so you may, why did we choose working with Coveros? Well, we've worked with several other companies, over the years, and we want a trusted partner. As a company that works with a lot of clients in safety industries, in high assurance environments, we want a trusted partner that we know will do a good job every time. And one of the things that we've enjoyed really working with Coveros is whenever we have a client that works with us and Coveros does our implementation work with them, we get the same skilled people every time. We don't get the newest junior person off the bench. We get people who've worked day in, day out in the industries, who know pipelines, who know quality, who know spiroplan, who know our entire tool set. They are partners and they live and breathe this stuff every day. So if you work with us and work with Coveros, you're getting not only a world-class set of tools, you're getting world-class consulting that lives and breathes our products. And they're integrated tightly into our development process. They get the inside track on all the new features coming out. Many of the things in our backlog come from ideas that have come from Coveros and their teams. So it's a two-way street. As you work with them and we learn from them, we improve the product, and also they get the latest information that we're working on so that they can bring those new features and new ideas to you as well. So I think that's some of the really important aspects of working with Coveros, but also they bring some amazing deep expertise in pipeline security, DevSecops, performance, which we're finding is increasingly needed by our clients, even if they don't know it yet. So I think it's really good that they have that. So with that, I would like to hand over to Jeff Payne from Coveros.
Thanks, Adam. Welcome, everybody. Really appreciate that introduction. And I'm going to talk a little bit about a concept called quality gates, which is the way you can leverage the Inflectra product suite, not only to do your automation, but also to bake quality into your development, your test, and your delivery process. Can you advance the slide, Hugo? So real quick, I'm old too, just like Adam, been around for about 30 years in the software industry, have built a couple of software companies over that time, and have been running Coveros now for 13 years. I'm passionate about Agile and DevOps, but my background is software assurance. It's how do you test and secure applications as you go. And so that's a particular area of passion for me and the company, and we help many organizations figure out how to do that. Next slide, Ugo. So let's start off real quick with a couple of terms, make sure we're all on the same page when we talk about these things, and then we'll jump right into quality gates and what they are and how it all works. The first is DevOps. By now, everybody knows that DevOps is getting everybody involved in the software development, test, and delivery process all on the same page. So making sure that development, ops, test, security, performance, everything is in sync and everybody is working to build and deliver applications that are reliable and secure. DevOps really came about because of an age-old tension that many of you, I'm sure, have experienced in the software process. And that is where there was a real dichotomy of goals in the software process. The development organization is typically driven by and incented to create more and more features as fast as possible, because the goal, of course, is to get new capability into the hands of customers. Operations, on the other hand, though, has traditionally been compensated and cares a lot about stability and security and making sure things don't fail in production. And that's created a lot of tension as development has tried to push new functionality through into production, and operations, knowing that those changes might break things, really pushes back on adding more features fast. DevOps is about getting these two very divergent types of organizations all working together so that we can, as I always say, have your cake and eat it too. Hopefully you can do things in a more rapid fashion that gets value to customers quicker, but do so in a way that when things go into production, they actually work. Fancy that. And we don't have downtime and availability issues. Now, you'll hear people talk about DevOps pipelines, which are really just a set of tools, technologies, and processes for code to move all the way from our development teams through our testing environments and ultimately into operations in a more automated fashion than we've done in the past. We're going to talk a lot about pipelines and how these things called quality gates fit into that. Next slide, Ugo. So DevOps and DevSecops pipelines. And incidentally, I didn't mention DevSecops. So people use this term in a wide variety of ways. Some people use it as DevOps on steroids. Right now, I'm going beyond DevOps to incorporate things like security. I personally have always believed that if security is an important part of your delivery process, well, then it's part of DevOps, right? You don't need a special name for it. But other people are using it to focus attention on security because security has often been a very late life cycle hurdle to get into production. And so the DevSecops movement is all about how do we break apart all that security analysis that we do and we need to do to protect our customers, and how do we move that to the left toward development, where we can hopefully find those kinds of problems earlier, fix them quicker, do less rework, and not have big hurdles at the end of the process. So whether you call it DevOps or DevSecops, it's all about how do I have my cake and eat it too, build something fast, but make sure that it works and it's secure. We want to move, when we talk about our pipelines, from what I call the code-focused types of quality and testing that we want to do to a quality focus and to a delivery focus as we go from left, which is where our development environments and our development teams live, to the right where operations and production lives. I found that different stages in the DevOps pipelines that you typically go through have different focuses in terms of the types of testing you're going to do and the types of criteria you're going to use to determine whether the code is good enough to move forward. And we'll talk about each one of these stages and the kinds of testing and how you verify that you're ready to move forward. I always say it's moving from speed, which you want over on the left, you want to rapidly test changes that are being made in development, to at the end, before you go to production, having no big surprises, right? You don't want to get downstream and find out something just doesn't work at all and you have to move it all the way back to development and start over. Next slide, Ugo. So in our pipelines, there's all sorts of tooling. Adam's been talking a little bit about continuous testing tools and tools to manage the process, tools to plan, tools to trace, et cetera, et cetera. In our DevOps or DevSecops pipelines, there's lots of tools that we want to integrate in to help automate this process of code moving from development all the way into production. We've got what we call continuous integration tools. These are tools that continuously build, test, and integrate our code as we make changes day to day in our environments. And we'll talk more about the CI process, as it's called, in a bit, and the quality gates for that part of the process. Then we have our continuous deployment tools. These are tools that help us stand up and tear down test environments, set up our application to be tested, install it, configure it, and then kick off our testing to make sure that we're doing adequate testing as we've defined in each step of our process. We have our continuous testing tools for both functional and non-functional types of testing that automates the tests that we're going to perform during our DevOps pipeline. And then we have tools that help automate the orchestration of things in our pipeline, the moving of code through the process as it passes its tests, the making sure that if we're using containers or other types of mechanisms to move pieces of our code through in smaller batches, that all of that is orchestrated and set up properly. If we have pipelines that feed into other pipelines because of the complexity of our system, that all that's orchestrated properly as we move code from ultimately development into production. So a lot of tooling and a lot of automation capability. One note is, fundamentally a pipeline isn't just about automation. It's a process you're following. It's a process from going from your development environments through all the testing into production. And initially, that's probably a manual process, and there's nothing wrong with that. But your goal in DevOps should be to be looking for ways to speed up and automate those manual processes, particularly those that are very fraught with risk and or often break, to start to automate those using these kinds of tools so you can make your delivery process faster and faster. Next slide, please. So let's talk a little bit about quality and security gates. And the graphic I'm showing here shows a very kind of standard pipeline that you might have to move code from your development teams, shown on the left here, through all the way into production. And I'm going to talk about each of these boxes because they do associate with this idea of quality that's and testing that's done that's code focused, then quality focused, then delivery focused in the process. But notice these little stoplights that you see, that you say green or red. These are our quality gates. These are the evaluations of the quality and testing that we've done at each step in the process to determine whether we have enough confidence in the quality and security of the application to move it downstream toward production. And so these are really the things that make sure that we're not pushing code into production or even downstream that's not ready to be moved downstream. Those of you involved in testing, this is something you've dealt with your entire life, right? How many times have you received something from someone before you who did analysis or coming out of development, and when it came to you, it really wasn't ready for you to perform the testing that you needed to do? Quality gates, the goal is to make sure that we are never pushing code too far into the pipe if it's not ready based on quality. Next slide, Ugo. So the first piece of this phase, this is really our continuous integration process. It's termed here build-in integration. And this is where we check in our code. So developers are working over here on the left. They're checking in code constantly, every change. When that check-in occurs, our automated tooling identifies that a change has been made. It picks up that change and it does some level of lightweight testing and analysis on that code to see if it's okay to be checked in. Usually that's based on some kind of criteria that we have on the goodness of our code. This is why this kind of testing is code focused. It might be unit testing. It might be quality or security standards for the code, so static analysis on our code itself. Some level of checks that we've decided as a team is necessary for code to be sufficient and good to check in and integrate. Assuming those tests pass, at some point, we're going to take a series of changes that have been made and we're going to integrate them together and we're going to regression test them. And regression testing at this point is really automated testing, looking to make sure that anything we changed didn't break something else, because we obviously don't want to push code downstream if our changes or our new features broke some other capability that used to work. That's what we call our CI process, and our quality gates there are all about the code itself. You know, do the units we build work? Is the code quality and security good? And can we integrate, and when we run tests that used to work, our regression tests, do they still work or not? If it fails, we got to triage it and push it back and you know, fix it. We don't allow that code to move forward in our process. Now, these tests are going to be 100% automated because this is something you want to be running very rapidly. Next slide, Hugo. If things do pass that, then we move into our quality assurance aspects of what we're doing. And this is our QA focused testing. Here we're doing our standard functional and non-functional testing that our quality assurance teams are typically doing as part of our Agile or our teams. And we're usually doing these both manually and automatically. Now, if you're doing continuous deployment where you're trying to push every change into production automatically, then all your tests are going to be automated. But in the situations Adam mentioned, where you're talking safety critical, mission critical, security critical systems, business critical systems, there's often a lot of testing you have to do manual that you just can't automate. So this testing will be part automated, part manual. And as Adam showed, you're going to look at the dashboards and criteria around, do these tests cover, right? Do they cover the requirements? Do they cover the use cases? Do they cover the different safety cases that you've created? And only if it passes those as your quality gate are you going to let code move down into the next stage of your pipeline. Next slide, Hugo. The last stage is your staging and pre-production. And if you've done this process right, you've moved as much testing as possible into your build and integration and your quality assurance. So you've shifted it left, such that the only things you have really left to do here at the end are anything you can't figure out how to do earlier in the process. And in a good DevOps maturity model and improvement model, you're constantly looking at shifting left. How do I move things out of staging and pre-production to do them earlier? Because really what we want done here is only the things that we call delivery focused testing, right? Our final tests, our final checks, any third-party audits, independent verification and validation, you know, authorizations to proceed, compliance checks, you know, internal audit, if it's going to regulation, all of those things need to be wrapped up, obviously, before we can move our code into production. And those are the kind of things that we want to be focusing this stage on. Our quality gate here is a go, no go on moving to production. So it's, have we gained enough confidence that we feel this is an application and a candidate that we can put into production? We'll go next slide. So that, with that as a backdrop, Ugo's going to talk a little bit about how you realize all this stuff. What does this stuff look like in action when you're using these tools, when you've got quality gates set up, and you're pushing code through pipelines into production? Ugo, you want to take it from here?
Yes, thank you, Jeff. So we're going to be talking about how you integrate DevSecops pipelines with the Spire family of tools. And this presentation applies to Spire Test, Spire Team, and Spire Plan. My name is Hugo Sanchez. I'm a managing consultant with Coveros, and I serve the Spire product family users in our company. We're Coveros, a services firm that serves Inflectra customers, and we've been building pipelines with our customers for over a decade. This is the sample application that we're going to be using as part of this presentation. We build this application from the ground up using a variety of agile development best practices such as BDD and TDD. And specifically, we use technology to be able to assure that the quality levels as required by the business needs of the customers have been implemented in this application. So these are some of the technologies that we have used, and you will be seeing how technologies are used during the pipeline. We make representations of the real life application using artifacts in the Spire family of tools. We use releases, we use requirements, we use test cases, test runs, and we use the product QA dashboard to make the decision, are we ready to release or not? The demo pipeline that we have has 4 different segments. The first one has to do with the management of the code. Then what we do is we check out the code, we create a build, and we run a series of pre-deployment tests, including unit tests, security tests, database tests, and automated acceptance tests. Then we deploy to a test or a QA environment. And there we then do a series of what we would call quality assurance and staging stage operations. We do API test, we do UI BDD tests, UI tests per se, then security, and then we do performance tests and mutation tests, and then we also create documentation. The pipeline can then be used to deploy to the next higher environment, which could be probably a staging environment, or if you're working directly with a website that will distribute the application to your customer, you can then post the product for distribution to your customers. These are the technologies that we have implemented in our demo pipeline. So if you're interested in talking about any of this later on, we will have people in our booth that could answer your questions, but you will see all of these in operations as we do the demo of the pipeline. The question then becomes, how do we integrate this pipeline with the Spire family of tools? The Spire family of tools deals with releases, requirements, test cases, test runs. It has a product dashboard that allows to make a release decision. So the state of Spire artifacts can trigger the launch or the run of the pipeline. The pipeline run then creates a build, and it triggers the launch of an automated pre-deployment test. Once those tests are completed, then deployment to test happens. And there, we run additional tests, analysis, and create documentation. We then update the linked requirement, test cases, test runs, and the product dashboards, and then users and managers can make an assessment of the state of the release and make a release decision using the dashboards. The pipeline can then be used to deploy to the next higher environment or to post the product for consumption by the customers. Okay. So now let's go in and see the demo in operation.
I would like to show you the initial state of the Spire artifacts for the demo application before we run the pipeline. So obviously, on the Inflectra demo product, we have our first demo release. And that release, the tests have not been completed. We have completed the development of the requirements, and some of the tasks associated with getting this release to this particular level have already been completed. So when we look then at the requirements, we see that we have a combination of requirements here that we try to abstract so that they would be representative of what you would be using. We have a series of functional requirements. We have security requirements. We have API test requirements, UI BDD and actual UI test requirements, and performance test requirements. So in our case, when we look at, for example, functional requirements, we like to use BDD to develop those requirements. So for each feature, we write a story, and then we write a series of scenarios where you see changes. And what I have done here is we have attached actually a screenshot of the environment that we use to write the tests and the scenarios, so that you can see that there is a direct match between our requirements and what we actually use for testing. Okay. The other requirement that might be of interest here is obviously for security. We say all the releases need to pass dependency checks and a SonarQube security gate, which is status analysis. All the API tests shall pass. And then we also write, using Gherkin, a series of BDD tests that we use for our user interface testing. So as a librarian, I want to be able to have a UI for lending the book so that it's easily to provide books to borrowers, and then we comment and we have scenarios and we execute all of those. Obviously, UI tests shall pass, and performance tests up to 50 users. That's what we like to see. So we saw requirements, then we see that many of those requirements are actually associated with the tests. So for each requirement, we have one or more tests, and those tests are then associated with the actual tests that are run on the pipelines. So we have requirements, we have test cases, and since we haven't made a run on the pipeline, we obviously don't have any test runs then. So we will now go and run the pipeline. And then after that, we will come back and show you the dashboards. It's important also to see that when we see the release dashboard, we see that in effect, nothing has run. This will most likely also show the results of previous runs of the pipeline. So you might see some things either not run or not passing, etc. And as the quality level of the application increases, then many of these indicators will turn to green. We're looking at the Jenkins interface. To start the pipeline, we click Build Now. Once the pipeline is started, it checks out the code from a GitHub repository, and it builds it using Gradle. It then runs a set of JUnit unit tests. We have about 200 unit tests on this pipeline and are achieving a high percentage of coverage. The pipeline then runs a series of integration tests that also hit the database. We then run automated acceptance tests which are BDD tests, that is, behavior-driven development. We then run static analysis using SonarQube, and based on the result of that quality gate, it can actually fail the pipeline right here if it deems that the results do not meet the gate requirements. The pipeline then deploys to test, which is a QA environment. It's actually taking the build binary from the development environment and moving it to a Tomcat server on the QA environment and publishing it. Then, on this new environment, we start to run a battery of tests. We run API tests using PyTest, which is a Python-based testing tool. As you can see, then it does the user interface behavior-driven developer test using Behave. Then it is going to run the general UI tests, which are not BDD oriented, and we use Java and Selenium to do those. Then it does the security dependency analysis using OWASP dependency check. This test actually contacts the National Institute of Standards and gets the latest vulnerability counts for your components. Now it is doing performance tests. We can actually run on this demo pipeline up to 50 users simultaneously, running through a series of ordinary actions. We use JMeter to do that. And to reduce the runtime on this demo, we're actually limiting it to 30 users. Then we do a little bit of mutation testing using PyTest. These tests actually modify the test code and then runs the test again. The tests should then fail. If they do not fail, that means your initial test might be suspect, or you have, for example, fake unit tests that have been put in place to artificially inflate your code coverage numbers. We then update the Spira tool with the result of our test and actually create test runs. On the Spira test runs, we create links to the pipeline test results, so then you have all the test result information in one place. And after all of that is done, we create documentation in the form of Java doc based on comments from classes and methods. What I would like to do now is to show you the results of the pipeline run on the Spira family of tools. And I'm going to do this in the opposite order that I showed you before we ran the pipeline. So we're coming here to the Inflectra demo product, and we're coming to the overall testing dashboard. And as we can see, the requirements have now gone from not passed, not run, not cover to passed. The test execution status has now gone to pass, and in the test run, we can see the fact that we had a successful pipeline execution and that 6 of the tests passed, none of them were blocked or not run or failed. We also see from a regression point of view that all our requirements are now passed. So in general terms, we're in fairly good shape. And we can also see how from a pipeline point of view, from a release point of view, the test summary is that everything has passed. What I would like to do now is show you how we bring some of the information back from the pipeline run into Spira. So let's go and see some of the details. What we see now when we go to the requirements area is that all the tests have been run that everything passed and that we have good test coverage in our requirements. What we can also see from a test execution point of view is that when we go look now at our test cases, we see that they have all passed, but we have some interesting information that we bring from the pipeline. For example, when we're doing a UI BDD test, we look at the information that came on the test runs, and we have the ability to now take a look at some of the reports that were created during the pipeline run. So what you're seeing here, for example, is a Cucumber report that tells us that we had a certain number of features and that all but 2 of them passed. So we're fairly good from a passing point of view, from a coverage point of view. We can take a look at the features. 87% of them pass. We can take a look at the scenarios, and we can take a look also at the steps. Of interest also is what this thing will show us. Obviously, a user being able to log into the system, we see the requirement. As a registered user, I want to be able to log in so that I can use the system capabilities. And as I showed you before, we have a series of scenarios and we have a series of steps that we have the ability to put in. And in effect, the system ran through all of this and they passed successfully. The question becomes, what happens to the ones that don't pass? So let's take a look at some of the features that have not been completed from a development point of view. So take a look at that particular one, and we see here then that some things pass, but some things are pending, and therefore they fail from an overall point of view. And it points to us specifically where the failures were and where the area of concentration needs to be for the development team in order to be able to complete the development so that those features can pass. So all of that information is now brought back from the pipeline run so that it gives you information directly on spiroplan based on the work that we did. I also wanted to take a look at what happened with our security tests, because we bring some interesting information when we run security tests. I look at the security test case, and now I am looking at the security test run, and I have the ability to access directly from my Spira toolset the results of my dependency checks. And as I said before, the interesting thing about dependency checks is that applications nowadays use so many components that are developed and supported by other people that even though we haven't made code changes, those individuals or organizations might have made code changes that affect the security posture of our applications. So one of the things that we do when we run our pipelines is we do what we call a dependency check. Using an OWASP tool, we go to the web, we gather the information, we compare it with what we have, and here is the result. It's showing us that we have all these different components that we have brought in that are developed by other people, and whether there is a CVE count against those particular components or not. So it looks like everything is checking out okay. So nobody has made any changes that should force us to update those components because our security posture is still fairly strong. And if you want to see the details of the dependencies, the versions that you're using on this build, etc., all of that information is right here at your fingertips. Okay, so we went and we saw not only the information at the dashboard level to be able to say, hey, we're ready to release or not, but in effect, what we did was from the pipeline run, we updated the state of our artifacts, of our requirements, of our test cases. We see that they are now all passed. And also, we can see the details on the test runs, and we can actually see information about what is it that we did, when it was done, and links to the build in which this test took place, and whether the thing was positive, whether it passed or not. So this now gives us a fairly good level of confidence on the fact that we are in a good state from a quality point of view on our release, as indicated by the artifacts in the Spira toolset.
All right. So as you can see, we updated the releases, the requirements, the test cases, and the test runs. And we also updated the QA dashboards so that are we ready to release decision can be made based on the runs of the actual pipeline. So what are the key takeaways? The move to DevSecops is happening, and that testing needs to be involved. Otherwise, what ends up in production might not be what you really want to be from a quality level point of view. Pipelines enable rapid feedback, help you identify defects from your customers, and the ability to fix them before they hit production. And if you have the Spira toolset, you already have a foundation, and we can integrate those for you with your existing pipelines and with your toolset. So now I'm going to hand that back so that he can talk to us about lessons learned from years of building quality through pipelines at Coveros. Jeff?
Thanks, Hugo. Yeah, just real quick. So when you're building pipelines and you're putting quality gates in place, there's some things you got to make sure you do right. The first is you want to start very simple with your gates, right? A lot of times organizations, when they first put together their process, they don't have anything automated in place, and so it's manual. That's fine. But as you start to put automated checks in place to see whether tests have passed and whether code is ready to move forward in your pipeline, start simple. And what I mean by that is don't create some onerous quality gate sorry, that nobody can pass in your organization. We see this happen a lot. You know, QA or security will show up and they'll want to put some gate in place that is impossible to jump over. That's the wrong approach. You'll be looked at as the quality police or the security police. And as we're going to talk later, that's going to cause some pretty significant challenges for you and for the quality and security of your application going forward. So simple, start simple. We always advocate that when you're going to put a new quality gate in place or security gate, you start with it just being a warning, which means if code fails it, you let the code continue to go through like it was before this gate existed, but you send a note, an email, whatever the mechanism is to communicate issues and warnings and failures back to your team. You note that it didn't pass the quality gate. And as part of the team that's putting this infrastructure in place, you're going to have to monitor this as well and notice when particular developers, testers, anybody in the process isn't meeting the quality gates that you need. And you're going to have to sit with them and work with them and get them to understand what it's going to take to get past the quality gate. So some of this is knowledge transfer, some of it's education, and some of it is just sitting and working with the teams to get them to understand what the expectation is from a quality and security perspective for the software that's being built. Then you can start to ratchet that gate up. And what I do usually is I start with a warning, but when I sit down with the teams and talk about the warnings that are happening, I say, you know, right now this is a warning, but this is an important gate to get in place. because we don't want things to go downstream and have issues in them, and we want to fail fast. And so it is going to become a gate. So let's work together to figure out how to make sure you don't have these issues, quality, security in your code, so that when it does become a gate, you're okay and you're going to pass. So that's point one. Point two is focus your initial gates on the code focus gates, meaning those up front in your continuous integration process. As mentioned, continuous integration is all about rapid feedback, figuring out whether the code itself is high quality, is secure. As part of our check-ins and our integration and our regression builds, those are great places to put gates in, because if code isn't good enough to pass your continuous integration process, you're really wasting time downstream, and putting gates later than that is just going to mean lots of rework, as a lot of things that could have been found earlier weren't. The third, as I mentioned, is to expect that you're going to have to coach teams and individuals on how to build code to be secure, build code to be high quality, and also run the quality checks themselves locally. One of the best practices for development teams in DevOps is to allow and enable your developers and your teams to run and check their quality gates before they even check in code. Give them some insights and help on passing these things so that they're not surprised when things don't work. Last but not least, if you don't start simple with warnings and gradually build up to good quality gates, what I've seen happens is teams will circumvent your process. They'll work around you, mainly because they're being pressured by development managers and other managers and business people to drive more and more features through the process. And if they can't get past your gate, they're going to get frustrated. I'm actually familiar with a customer that, here in the DC area, a large financial service organization that for years has bragged about the quality and security of their applications and how they never find any security vulnerabilities in their code as they're going through the deployment process. We had the opportunity to do an assessment of their DevOps process and practices. And at least in one instance, one of their major programs, the reason they were never finding any security issues was because development had turned off all the security checks. And it really got down to they couldn't get around them. They couldn't figure out how to get over them. They were frustrated. They turned them off temporarily while they worked to figure out how to make it better. And they kind of sort of just forgot to ever turn them back on. And so it wasn't that their security was good. It was that they weren't even checking their security. Those things are going to happen if you don't figure out how to put gates in place gradually and help the teams learn how to build better software in the process. Next slide, Hugo. So for those, as Hugo mentioned, our business is all about helping organizations deliver secure and reliable software using agile methods. We help people with a wide variety of things we've talked about today, everything from testing and test automation to integrating security to setting up pipelines and just doing things in a more agile way. We have coaching, consulting, and implementation services, training services in that area, and a number of open source products that we've built as well and we maintain. We have a wide variety of customers. Here's some of them. If you want to flip to the next slide, Hugo, here's some other ones. So if you're looking for help and support, you want to improve your capabilities, improve your people, we can certainly help you in these areas. Next slide. And I think we're back to you, Kim.
I think Pam's going to do some Q&A.
Yeah, absolutely.
So Pam, thank you.
Absolutely. So we have a couple questions in the chat, and then I have a couple other questions that I received. I'll start first with Miriam's question. She asked, if you're a project manager and not a programmer, how can you understand the code aspect of the impact of a bug?
Yeah, I can take a cut at that. I saw that I think Jason Hawthorne put a great answer in as well in regards to thinking through, kind of the impact of the bug in terms of what kind of bug it is and where is it in the application, and how often the customer's gonna see it. The other thing I would say, and I didn't talk about this when we were talking about the overall pipeline and the quality gates, was there was some feedback loops in the gates. If you noticed, we were focusing on, what happens when the code, the application passes the quality gates and moves forward. There were also some failure, right? The little red stoplights in my diagram that was what happens if it didn't work. And one thing that's important in a DevOps process is when any of the quality gates fail, there's a number of different reasons why it might have failed. It might be the code. The code might be incorrect. And to your point in this question, you're going to have to figure out the impact of that in terms of what it's going to take to fix and other impacts around the code itself as part of that triage effort, if you will. It could also be the test, though. Sometimes tests time out, sometimes tests break, they're brittle, and sometimes that means that it's actually the automation of the test that's broken. The code works fine. Third is that when you start automating your setup of environments, your teardown, right, the movement of code through your process, it might be your infrastructure as code, or the way you've set up your Docker containers, or the way you're orchestrating, deployments of things through the process. And therefore, it might be that we call it DevOps code, right? The code you're using to automate that entire delivery process. And so what I recommend is that whenever a quality gate fails, you need to have a very small triage team. It needs to be a team, right? You need to have someone who represents development and understands code. To your question, you need to have someone from test that understands test and test scripts, and you need someone from CI/CD, whoever is building this automation capability for your pipeline, to see whether it's the pipeline itself that's broken. They need to triage and figure out which thing didn't work, because that tells you who has to go back and fix the problem.
Great. While we're here, there's also a question from Chris. How do you manage the gates and dashboards and instances where everything isn't automated? For example, I want to run some more intensive testing and want to not progress until they are completed and evaluated, and I want to see the results and associated documentation in the dashboard.
Do you want me to take that one, or?
Yeah, I was going to say, Adam, take that one.
Sure. So that's a great question. And one of the things that why I think Spira gives you a great foundation, as Hugo mentioned, to build on, is that it was designed from day one to be both for automated and manual. So although the focus of Hugo's demonstration was really around the automated tests reporting back, all of those requirements in the requirements list that we had could have multiple tests associated with them, manual and automated. And for the manual ones, you basically have the users do what they're doing today in terms of their manual process, but Spira has a place where you actually record the results live as you're doing it. So as an exploratory tester is following their test charter, or maybe it's some smoke tests, maybe it's a more traditional semi-scripted kind of test because the app isn't really automated, it's changing too much to be automated. Whatever is the manual process you're following, the UI of Spira has a place to actually run through it, put the results in, and those results update the release, the requirements, all the same artifacts that Hugo demonstrated, but it's done by a human. In fact, that's one of the nice things, is that literally everything in the system can be updated from either an API call, which is what is being used here for the automation, or it can be done inside app using human logging results. So you have that same traceability and auditability, whether it's manual or automated, and a single decision about being able to go live as well. Sorry.
Right, and what I was thinking was that one of the interesting things as we develop the pipelines is that combination of automated tests versus manual tests, automated decisions on the gates versus human-based decisions on the gates, and how you first try to automate a lot of what goes in the code portion of the gates, and then while the rest of the process is manual, and then you start move from left to right from an automation point of view and start to do updates via the API versus via the user interface, which is the way you normally start first.
Mm-hmm. Mm-hmm.
Yeah, and I would add to that, Ugo, that while the demo that Ugo showed was showing code moving all the way through the pipeline, using automated tests and automated quality gates, to your point in the question, I mean, for most of us and for our environments today, we're not there, right? We're not there. It's hard to get there. Sometimes there's constraints around the environments and access to them. Your ability to automate this, the testing on those environments. It's obviously really a lot easier to do all this if you're in the cloud. But at Coveros, we've helped a lot of people who are on-prem and using mainframe or other legacy systems, at least on the back end, to figure out how to do that. And you can set your pipelines up so that they can either automate that quality gate process, or you can flip a switch and do what we call push button deployment, which means at any step of the way, the pipeline can pause and notify someone, using, chat or using some other capability, whatever you're using to drive interaction, to let somebody know, I need for you to get into Spira, I need for you to look over the results. And if you make the decision that it can move forward, you can hit a button and the pipeline will pick back up, just like if automatically it had been told to move forward, you've told it manually to move forward. You could set up a push button at every stage and then into production so that you've got full control if it's not a completely automated process. And that's really easy to do if you set things up properly.
So there was a follow-on question on the way we presented the test on the pipelines. We presented families of tests. There were individual tests that were run on the pipeline, but the way we represented them in spiroplan, we represented them as family of tests. What we would not do on our pipelines is there will be an almost one-to-one relationship between the requirements and the test cases and the updates that are brought back to the pipeline.
Right. Yeah, I think, I in the demo, I think it was simplified to make it easier to see what was going on in a demo environment.
Yes.
Actually, if you look at that BDD grid that you had, every single one of the scenarios in that grid could be its own test case and would report back.
Yes.
You'd have gotten past and blocks, but in a demo, it would be a little bit hard to see what was going on.
That is correct.
So yeah, so that's a great question about traceability. You need the right level of granularity.
It has to make business sense.
Right,
That's the decision that you.
But you can also go the wrong way. You can also have like a 10,000 test cases. Every single line of code reports back individually, and then that can be just as crazy as having like one. So there's definitely, I think, a sweet spot between infinite granular, it's so granular you can't make any decisions, and like one functional test that's passed, which agreed doesn't let you see which requirements were impacted. So, but drive from the business. The business needs to drive what granularity makes sense for you.
Yep.
All right, I have one more question, and I bet everybody else is itching to get back into the creative space, but we have one question that says, how have you seen Spira tools used in a regulated environment, like a software application that has to go through an FDA approval process?
Do you want me to talk about that one? Then
sure.
You maybe talk. Okay, we have quite a few clients in this environment, so there's several different aspects in that question, probably each of which would be probably an hour, but
yep.
At a very fundamental level, you have to validate this. First of all, you have to be able to set up Spira in a way that meets your validated process, and we have best practices to do that, and Coveros helps many of our clients do that. You also have to validate Spira itself in place. So that's another thing you'll have to do. You'll also have to usually have, if you're doing our cloud version, you'll need two versions, one that we auto update and one that's static, that's locked on versions. So there's some specific things we have in place to make that easier. Obviously on-premise can be done as well. And then documentation and again, granularity. How much are you going to sign off on? Are you signing off each individual test case with a signature, with an e-signature? Are you signing off every release? Are you generating test documentation and signing that? We support all those different levels in the tool. a lot of it depends on your process, because if you've got a process that's very document centric today, you don't want to suddenly throw that all away and become very granular and having all of your BAs and testers having to sign every single test case individually. They're just not used to that approach. So you want to take baby steps to implementing a system so that you keep your process as close to its current state and improve it in an agile way, sequentially and iteratively. So I think understanding how the tool it will support your regulated process is really important, but we have many examples of doing just that.
Now, the areas where we have seen the greatest impact is in the generation of documentation for regulatory purposes to get approvals. We have seen customers go from spending months generating documents to now spending a number of days generating those documents, because the tool is used to capture the information of the work that is being done and then to assemble all that information and present it in a way that is recognized as valid by the authorities. So it's bringing agility to the business process of achieving the regulatory approval.
That's right. Interestingly, we have an internal audit every year from our life science validation partner, and they typically would schedule with other companies a day to do this validation for us. They validate the software, all the requirements, our dev processes. We were able to do it typically in 2 hours because everything is we use Spira plan ourselves. All the information is at our fingertips on the audit, and it's amazing how much time, even just the audit itself, is sped up because all the information is very linked. There's traceability, there's auditability, the data is right there. We can go through it with them, following the links in the application, versus going to a filing cabinet and trying to dig up test plans and test documents and trying to find which requirements on which page, which is on which Excel sheet, which is what you would do in the old days, which is crazy.
Great. Well, thank you. Kim, I think back to you.
Thank you all for coming. I'm sure you learned a lot from our great presenters. Thank you, Adam, Jeff, and Ugo. Now let's go have some fun. Please join us for a meet and greet in Creative Spaces. Creative Spaces is the fun environment that lets you, your avatar, walk up to people face to face, have a discussion just like we were all together. And if you like the environment, please come see me. We can build and brand one for you. It's great for internal company meetings, sales, customer calls. It's endless. So I'll see you guys on the other side.